This notes will be very minimal, and I'd like to put only the essential points which are related to the cloud computing. We'll try to learn it in a sequential manner as much as the detail that we see in our practical session in the upcoming classes. So we'll try to learn more and more ideas as and when we plunge upon the practical thing. So you will be able to correlate what we are speaking and how that is working, in reality. So cloud computing. What do you mean by cloud computing? We have discussed it about it in abundance for the past 2 days. Now we'll try to put some solid kind of sentences so that we'll put our understanding in the form of writing. We'll reduce it to writing because why I say reduce it to writing, because you write something, you can't represent everything that is over there in the market, the way it works, the way it can be described. There is no limit to how you can describe it. You can put that in n number of forms of oral expression or writing, but when you have to write something, you are really reducing it, you know what you can explain about it. Cloud computing is delivery of computing services over internet. What is computing services that we can think of? Computing services that we can think of is machines. If it is client, we call it as simple machines. It could be a laptop or a desktop, but still even these laptops and desktops, just assume, I will put one situation why we should use VMs and why not laptops or desktops for the purpose of connecting with the data. Why we should only use VMs? Assume that you have a client laptop, your company would have provided a laptop, and you don't have a VM provided. You would have seen all of the companies are giving you access to VM. If the clients are from banking or insurance or healthcare domain, they definitely expect you to do everything in a virtual machine only. You'll be able to log in remotely into virtual machine and do everything there. Otherwise, even you would have seen this scenario where VM was not provided. Assuming that your laptop is completely secured, access is being secured, and you have the SQL Server, everything development and environment installed directly on the laptop, you will be connecting through VPN. You will have connectivity problems. And when you connect to a server, say a SQL server, and you try to fire a query, which is fetching you at least 1 lakh records, and you can see how much delay it takes. It may take up to almost half an hour to execute that query. If everything is loaded in your laptop or your desktop, unless you sit very closer to the server, this data loading will take huge lot of time. It's a wastage of time, right? Simply. So VM, so virtualized machine, this VM will be located very close to the server, and it's only that interface will be exposed to you over internet, and you will be using VM to connect to the database. So since your VM as well as SQL Server are located almost in a close proximity, you don't find so much of delay. It will come in few seconds, just like that. Okay. So VMs, VM is a strategy actually to have the things. You can even suggest if something like this is getting delayed in your work, and if your organization is asking for some suggestions, you can tell them, see, instead of loading our laptops, you can provide VMs wherein you can secure your data security concern will be addressed there, as well as latency issue when you are developing. So this is the ideas. By having this understanding, you can always give this suggestion to your company, so they will recognize you as a valuable asset. Yeah. Next is storages. When it comes to storages, we call everything as data, and we know at the outset how many categories of data you have: structured, semi-structured, unstructured. You have any amount of data, you can categorize into any one of these. So storage is one critical thing. And databases over and above storage, you will have a formally organized structure, or a container kind of thing, a database, a software container, wherein you hold the data there, and it will be managed completely throughout its life cycle, data life cycle. That's what we call as databases. And networking, and the list keeps on increasing. This is what Microsoft is saying: an ever expanding list of services, ever expanding list of services. Because see, this is a service model, it's not a product. You are not owning any database or data center. If you are owning it as a product, then you need to have someone to administer it, and that's a very big overhead for you to maintain and run it. Since it is being like hosted by your cloud service provider, you are just using it, which means that the examples that I have told you previously, if I have to use a car, then I need not have to buy a car myself. I can just call Ola and Uber and just pay them for the time and distance that I have traveled. So it's a function of both time and distance that they calculate the money that you have to pay at the time, and then just get the services. So similar kind of thing. Okay. And now, in addition to these things, we have some wonders when it comes to data engineering. The scalability is one of the features that we will look into that aspect of it. And scalability with respect to data engineering, we are using something as cluster computing as an underlying feature. So if someone, in a second round or third round of your interview, if they say why is really cloud is so good, even they may or may not know the actual fact, or they may be testing you how much you know and what opinions you frame about Azure Data Factory, Azure Databricks, or things like that. Then this is the answer that comes handy to you. Then you'll have to take, if you really want to have extract more value from data, and you want to derive the benefits of cluster computing, that combined with elasticity. Cluster computing is a group of computers working towards a particular objective or goal, or computing end result that we are looking for. Which means that if there is a particular data load, I have 17 crores of records which has to be run using an SSIS package. And this SSIS package for this 17 crores of records may be running to 10 or 11 hours of time. But if you use cluster computing mixed with scalability, this 11 hours of time will get reduced into 11 hours will get reduced into less than 1 hour. So you see this benefit. It's clearly you are able to see this benefit. The kind of computing capability that we are having. We are having clusters. We can define the size of the clusters, and we can define maximum number of clusters that we can have. So that clusters will be spinned up within few minutes, and the computing power will be available to you in an instantaneous moment. And your workload can run on that in a parallel mode, and you'll see the benefits derived out of it instantly. This is what we call it as a primary benefit. So you can say, if you really want to derive the benefits of cluster computing, along with cluster computing, running workloads of data science, AI, and ML, These are, you can discuss about these three topics for almost 2 to 3 days, but I try to put that benefits of these three. So you can't even tell. That's an ever expanding list of benefits that you derive out of this. But every business is trying to find out how they can benefit using these technologies and techniques. So definitely these are like, trying to extract more and more value from the data that you are having. If you have to extract more and more value, you have to process it so thoroughly, right? You can just think of it like, if a gold as a mineral, if it has to be mined and purified, how much processing it will undergo. 1 ton of this mined material, or that mud, from a gold mine, if you process that, you will get 10 to 20 grams of gold. 1 ton and grams, and few grams of gold is what, so much of processing will go into that. So if you really have to process that much of information, which is equivalent to the gold, then you can imagine the amount of processing that this demands. If such amount of processing has to be done, then you definitely have to have very good computing infrastructure. That's only possible with cluster computing. You will be massaging your data like anything in order to ensure that your algorithm is extracting that data value from the data that you are having. So this is about scalability. We are able to scale it on demand. That's one of the benefits. Also, if scalability, like, scalability is that's all everything. So which is hitherto means till now, when you have traditional data centers, suddenly, say, will take one very good examples of Ram Gopal Verma. He's a sensational director, and he likes sensation. So he suddenly released one movie almost in the middle of the night. That's when he usually does it. Somewhere in the middle of night at 11 o'clock, he does it. And you can see all the people are trying to have that subscription in that OTT and want to see that movie. And if such kind of demand is there, and you want the servers which is servicing the application which is selling this digital asset card movie on an OTT platform, if the number of users kept on increasing as the time passes by, like in initial 1 minute, you have so many number of users, second minute, third minute, fourth minute, suddenly you see 20 lakhs, 30 lakhs of people coming in. And if it was a traditional data center, definitely, it's constrained by the maximum amount of computing power or the digital infrastructure that you have, how many number of processors that you can have in one rack, how much of memory, RAM or hard disk that you can have to support this thing. Definitely it will crash. After a few seconds, you can see, it is constrained by the digital infrastructure that you are having. So definitely in the cloud, if you say elastic mode, then there may be idle machines which will definitely get attached to the uh, whatever is the servers that is servicing the, digital infrastructure. It will in a runtime, it will come and get joined, because everything is virtualized there. It's completely automated, and these service providers are able to, they need not have to do physical, fixing of wires and that communication bus that we call serial ports, parallel ports, power ports. Nothing has to be moved in a physical way. Everything will be connected, and in a virtual way, in a few clicks or in an automated way, they can attach or detach the additional digital infrastructure required to support your services which are hosting the load, digital load. So now we'll talk about responsibilities. You are hosting something as a digital service provider. You are a part of a company which is which is uh, which is running application, and still you are we know that we are hiring the infrastructure as a service. Infrastructure is digital infrastructure that we are calling. We are not owning it. As I told you, everything is a service. Because you have seen this computing, cloud computing is delivery of computing as a service, computing services. So the responsibility here in the computing, because we'll have hardware, we'll have the software, there will be hardware team. Even before hardware is there, what we have in our brick and mortar data centers, first of all we'll have to establish the building which comes under admin. Then we'll have to set up power and backup which comes under electricity services, administration, maintenance, and power backup. You need to have engineers or sub engineers who will look after the your power center and backup center. We'll have batteries which will be serving as a backup for a moment. So one above the other one, we'll have layers of things built upon each other, and then we'll see the creamy layer on the top of it, that is software, which sits on the top of all these things. Like you have buildings, and then you have the big AC rooms, and then power backup, and then you have the servers, and over and above the servers you have the operating systems installed, and over and above that we'll have the development environment or the required platform over which your software will run. Over and above that you will have data. Once your data is set in the application, that application will keep serving the uh, end users. End users will only see the cream of it. They will only see the cream of it. But every layer is vulnerable. If something below that, say something below the servers, that is power, is a failure, everything above will collapse. If your data server is not serving, so your computer will be up and running. Since your data connection is a failure, your application will not be able to connect with the database and service the database. So that's kind of, everything is dependent on something else. If such kind of dependency is there, then responsibilities will be shared in that order, in that stack. So the electricity team may be telling service level agreement. Yes, this is a service level agreement, which means that you will never see a failure, definitely, at any cost. That's the promise given by the power team. At any cost, you don't see any failure because they have the things kept in place, things put in place. Like, you know, you have the power which is coming from the substations, and if there is some failure, they may be running a backup center where they may be having a large combination of batteries there. They may be maintaining that, definitely, and that comes as a backup. As soon as you have UPS, uninterrupted power supply, they'll be doing scheduled maintenance periodically. They'll be testing it very often. They will have test modes and see if that is really working or not, and in the test mode they'll keep checking, ensure that it is not even a blink is coming from the power supply. So that kind of backups will be there. If such kind of responsibilities is there, then they will make SLA, service level agreements. Wherein they define the level of service that they promise to give to the next level. Power will give to the data center level, the hardware people. Hardware people will give some service level agreement to the people above that who are running the softwares. Ultimately, the one who sits on the top, if you are a manager or a delivery head of a particular application, then you know how these are dependent and where what is SLA and how SLA works and what layer, what which people are responsible for what kind of thing. Something goes wrong and your stakeholders are making, or it has become headlines in the middle of night. You know whom to contact and how to get the things done. You know who is responsible for that. If a hardware is a failure, you know who is responsible. We go and ask them what is the backup plan that you have, because as per SLA you are supposed to have a backup plan. Suddenly there is a fire in your data center. Before day you would have taken data backup. All of this would have been properly planned and will be ensuring. So this is what is ultimately shared responsibility model about, and we'll go more detail in that particular shared responsibility model. I'll try to give some details about that. Yeah. So we can see this. So I would like to take your attention first to the colors here, the color codes, how what it means. Because unless you understand that, you will not be able to make up some idea about how this cloud is working. So the one which is in blue, light blue or sky blue, that represents this is the responsibility of Microsoft. In our case, in this context, it is Microsoft, because Microsoft is a cloud service provider that we are talking about right now in this training program. And the one which is in dark is a customer, which may be you or your company. You may be a representative of your company, or you may be having IT team in your company. Still, their job is much easier now because this IT team is very lean now. They are literally not in charge of maintaining a huge physical infrastructure. They are simply hiring it from some other service provider. But still, you have a team. They may be a representative on behalf of your company. So this is a customer. It may be you also. If you don't have IT team, or if you don't trust your IT team and you want to directly connect with the cloud service provider, that is Azure. So this is something that a IT service provider company is. The Microsoft is cloud service provider. It's a responsibility. This color represents the responsibility. And you see this square block which is having half of the color as light blue and half of the color as dark blue, which means that the responsibility here is shared. That will be, you know, that sharing will be that sharing will evolve, or you can discuss and try to come up with some deal saying that this is what I am responsible for, this is what you are responsible for. It need not be 50-50. It could be something, it could be in any ratio that responsibility may be shared. So this is a legend that we call. So you see this is on-prem is a kind of digital infrastructure that we have been using before the arrival of cloud computing service. We call that as on-prem. Since the cloud has come, whatever is existing, that has to be given some name. That is something which you run it from your premises, so you call it as on premises. And opposite to on premises, you have cloud. So with the arrival of cloud, we have coined a new term called on premises, which are otherwise you don't have any name to it. Is something, you have to have digital services, then you have to have digital infrastructure for sure. So on-prem means this is how it has been running till ages, till most recently, till the arrival of cloud. Everything, you see, physical data center, brick and mortar data center is a building, a network. Yes, there is a team. Physical data center, there is a team to maintain it. Physical hosts, yes, there is a team also. Some of them may be belonging to network. And now, if you say infrastructure as a service, this is the kind of service that you want to take from your cloud service provider. Then, if you say I want the infrastructure as a service, then the Microsoft person says yes. His job is done when he is able to provide the VMs, physical hosts, not even VMs, the computing power and network and data center. They'll be taking backup and they'll be ensuring that the computing power is available to you. And over and above that, operating system. It's only the VMs which they will be providing virtualization and providing a kind of platform wherein you can install your VM. It may be your choice. You may want to run Linux, you may want to run Windows, you may want to run some other custom operating system. It is possible. Like if you go to DRDO, government's organization, they may not trust Windows, they may not trust Linux, they may have their own operating system. If they want to run on the cloud, they will have a completely secured operating system, and they may have their own operating system installed over the cloud service providers infrastructure. So you can see whatever is blue is the Microsoft responsibility over their infrastructure. So only the infrastructure which is provided by cloud service provider, and they would be executing SLA related only to the infrastructure, that is physical data center, physical network, and physical hosts. So this is one such model where the
Pratap,
liability.
one question.
Yeah,
So this operating system, so at the server level also there will be an operating system, right? And also in the
agree.
client machine as so which operating system like
Hmm.
IaaS is referring there?
Operating system. See, in IaaS, you see this dark blue color, which means that it is our responsibility. The one who is consuming the uh, cloud computing services. How much cloud computing services that you take, that's represented here, IaaS. In
So
IaaS,
that
see,
means
operating system, you may see it's not hard and fast tool that you have to use Windows, right? You may say, I want to use cloud, but still I want to use Linux, or I want to use Ubuntu. I may want to use some other operating system, but still I want to run that operating system on the cloud infrastructure, right?
yeah.
Agree that
And
kind of
suppose
scenario is possible. No?
yeah, suppose if a database say like Oracle is installed in Linux server,
Yes,
so in that case IaaS is not going to provide that Linux server.
they won't provide. You have to have that Linux,
Only
software.
machine they will give, right?
Only machine they'll give. Agree.
Okay, okay, got it, got it.
Only till networking they'll give. That means infrastructure is available. You just have to plug in, get your software loaded onto that, install that, and over and above that, the controls, the virtualization part, and over and above that, you install applications. So here only the physical hosts and networks and data center will be available. Any backups related to that, they'll take it. That's all.
Okay,
Which means
okay.
in the event of failure, they may say this is a service level agreement 99.99%. That 1% is the thing that will take. Even in that case of 1% of failure, we have systems in place so that after so much of time, you can be assured that the service will come back to you know green. This is that model. So it's our choice. It's our choice. So there is large bandwidth of the kind of services available from the service provider. So then platform as a service. Platform as a service is where, along with the physical networks, you have the operating system also given by the cloud service provider, which means that you simply say, I want VM. They will have some virtualization wherein they have their images. That images will be installed, and you have the Windows system like a VM, which will be available to you. And the kind of network controls, what kind of networking that you want to do, what are all the systems to be connected, that there will be mutual understanding between them. They say so many IP numbers will be provided to you, and you have to choose among those IPs. And that IPs will be available only for you and your organization. Be rest assured. There is a SLA which is covering that. And there may be applications. They say these are the applications that we'll be having. But if you want to have some license authorized, or you want to have the application, who are the team which may be supporting the applications, like you may have Oracle or you may have some any other database. If there is a problem with respect to that particular database, there may be a software team who may be supporting that. So you may want to purchase license to have that support. So it's a shared responsibility model again here in the platform. Identity and directory infrastructure. So you will have the identity infrastructure available with you, which means that you have an organization there. You have a physical organization. CEO is sitting below that. COO is sitting along with COO, CIO, and CHRO is sitting. And below COO, you have different lines of business directors and vice presidents sitting. And below that, you have the people. You have delivery managers, and you have team leads, and you have architects, and all those people are sitting. And this is a physical organization of how your organization is represented. And if you have to have identity and digital infrastructure for this particular organization, you have to represent that in terms of a kind of active directory. You would have heard about this active directory. Active directory is somewhere where you will have a kind of unique number. It may be your employment number, it may be your mail ID in your organization, it may be something which tends to uniquely identify yourself, or a login ID in a network that tends to uniquely identify you in that particular network. And you will have a password, and every organization will have a password policy also. This is your entry virtual. This enables your virtual entry into the company's digital infrastructure. So that's what is PaaS. This is the responsibility model shared here. Over and above this identity and infrastructure, what are the accounts that you create? If any new employee comes in, if any person goes out of the company, that has to be deleted. If any new person comes in, it has to be created, whether it should be created or not. Definitely, if a person leaves, it has to be deleted. That responsibility, that decisions will be taken on by the company. That's why it is in dark blue color on the PaaS. So limitation of the cloud service provider is only to that extent of providing this infrastructure, softwares and platforms. That is platform as a service platform. Means the service provider's responsibility is limited only to the platform. Over and above that, something happens because of some mischievous activity or some ignorance, cloud service provider is not responsible. It's an obvious thought. There may be some team who is responsible for doing this. Say, I'll give one scenario. There is a person and he left the organization. Obviously, the person who is leaving the organization would have had some bad experiences. And he suddenly turns out to be a terrorist. He want to destroy the digital infrastructure of that company. And if you really, the person who is in charge of that, who has given the relieving, has not taken enough care to remove the digital identity or disable the digital identity, and still this person is having access to the digital identity, then he may be an admin of network, admin of IT, who is having all the permissions. Then suddenly he turns hostile. He may destroy your entire digital infrastructure. He may create a lot of troubles to there. Who is responsible for that? Someone who is managing this. So definitely here, even the cloud service provider cannot enter this territory. He is only responsible till this place where you can see the light blue color. And then SaaS, software as a service. This is another model wherein applications, till the applications, they will be doing it. The best example is Salesforce, you can say, or SAP. They will have their own applications. You only have to customize it, directory and infrastructure, accounts and identities. Everything is there. It's a CRM, right? CRM. How you connect with your customers and what are all the features that you can leverage from application. The application will be given as such. The people who are using the application will be customizing that. Till the application, it's the responsibility of the service provider, SaaS. Whatever is sitting in that application, that's the data. You can think of it as Office 365. So you will be opening it from the browsers. It's only the data that you are owner of. The remaining everything is literally not there even with you. It will be there in the browser. You will be accessing it from the browser. There are lots of benefits that companies derive out of this kind of model. You can't download that entire document. It will be always secure. Even if they give Windows 365 or Outlook access from your mobile also, you can never download it. You can only read it or modify it. You can never download it, which means that it's secured, completely secured, but still you have access. You have permissions to do what you want to do. The document as such, or the information that the document is contained, that will be kept as a secret at any cost. So that is SaaS. This is where you have the least responsibility. This is where you have the highest responsibility. So many functions has to be done in on-premises. But in the service, computing as a service or computing as a service is what is cloud all about. The highest level of, the least level of liability is SaaS. Highest level of liability from our side is IaaS. It's only the infrastructure that is taken care by the service provider. Whereas in SaaS, they will have the liability till the place where you have identity and directory infrastructure. You can see this identity and directory infrastructure. Azure Authenticator, which you install in your mobile, scan it and get it activated. You would have seen, some of you who are working out there in some very good organizations, you would have seen that authenticator is coming in and telling that yes, you authorize. Even if you are doing it, it will enable, it will prompt you accept, deny. If you say accept only, then you will be allowed to log in. It's a kind of feedback which is working in there. That's nothing but identity and directory infrastructure. That's the limit there. Over and above that, accounts and identities, your company will be maintaining. Your accounts are locked. Somewhere you give wrong passwords, your accounts are locked. Still your company, you have to approach your company, because accounts and identities will be maintained by your company. You have to have someone who is an admin for that particular application, and he will enable that account again if you have really lost your password. So this is a kind of responsibility model. Shared responsibility model is what we call. And there are some scenarios. This is original documentation related to Microsoft Cloud that I'm showing you. So are you clear with this shared responsibility model? You can try taking Azure fundamentals examination as well as Azure data fundamentals examination. This will keep the ball rolling in terms of certifications for you if you are really interested. These are really very easy certifications, but don't worry about the money which they are charging. There are some kind of training programs, maybe 2 to 3 hours of training programs. If you just register your attendance there with your mail ID, then your mail ID will be linked with a coupon. You go and write, you can go and register for the examination free of cost. These are fundamental examinations. All the fundamental examinations are free of cost, provided that you are attending any one of the training programs which is related to that particular certification. This is one very good suggestions which will add some value to your resume. It's really free of cost. It's the only thing that you have to do is you have to register your attendance there and just be available there. You may be interested to listen that or not, because these are definitely the people who are speaking American accent English or Australian accent English or UK accent English, trying to deliver the knowledge over there. You may or may not be able to grasp that, but if you register your attendance, your mail ID will be authorized to have the registration to examination free of cost. If that is, if you are able to register once free of cost, then you will be able to attempt it and get that done. So you have one nice logo coming in, you can add to your resume, and definitely, hopefully, that will add some weight to your resume. Got it? Any doubts on that? You want me to guide on that? I'll definitely take half an hour session to guide you over that process. You can always approach me.
Yeah, sure, Pratap. That would be nice.
Yeah. So probably I don't know how many of you know it, but I know it because I was literally thinking like I don't want to waste so much of money. I've done it. I personally experienced it. And so there is an observation which they are trying to tell it. I'll share my screen now. It's a consolidation of our discussion some time ago. Yeah, we have seen the shared responsibility model here. Because if you are a lead of a team, then you should be able to discuss this with the architect or delivery manager or a manager. Because cloud is a kind of technology, we know the technologies will move very fast, but cloud is a kind of platform over which a lot of technologies will keep moving fast, which means that cloud will have a lot of traction and mileage at least for 15 to 20 years from now onwards. You can be rest assured that this cloud will be there, because it is a phenomenon in computing, and it will reduce a lot of financial burden as well as a responsibility burden on companies. You can simply plug and play the kind of model. Definitely, if something, so if business is going down, obviously, service providers has to reduce their costs, and it's a kind of balancing thing in play which will work in commercial world, and it will be mutually complementing. Companies as well as cloud service providers try to balance each other in terms of the cost of it. Now you would have seen some observation here. You would have seen some beautiful observation. They have consolidated that observation and put that in words here below it. A responsibility transfers to cloud provider. In any of these service models, be it SaaS, software as a service, as a platform as a service, or infrastructure as a service, maintenance of the infrastructure is a common denominator, which is a responsibility of cloud service provider in any of these models, service models. You can see this, any of the service models, it's always the responsibility will be retained by the customers, because this is a creamy layer of your digital infrastructure. This is a stack which every higher level of this particular block is dependent on the block below it. just like a building. This is a foundation. Above that you have floor 1, floor 2, floor 3, something like that. You can't imagine a block above without a block below it. That's how things are stacked in digital infrastructure. Probably you'll agree, because if there is any decision that your company has to take, logically you'll have to see where that block falls, what are all the blocks which are dependent on that block, what are all the blocks which this particular blocks application blocks is dependent on. This is what your architects as well as delivery managers who are responsible for delivering the digital services will be aware of. Definitely, probably somewhere down the lane in your career also you may progress, but still you need to have this kind of awareness when you are shouldering some kind of responsibility. This is a consolidated observation that they have made. You will always be responsible for information and data that you are storing. So you will be the owner. If something is gone wrong with the data, how to correct the data, that you will be taking responsibility, the owner of the data. Cloud provider is always responsible for the brick and mortar things, the physical things, the tangible things, which they can touch and feel in the digital infrastructure hierarchy or this order. This is what you can touch and feel. Other things is only you can feel it, you can't touch it. It's very soft layer. That's what you call as software. It's a hard layer, you call it as hardware. Yeah, obviously. So digital infrastructure is a combination of both hardware and software. And how is this dependency? And based on this dependency only you have the shared responsibility model coming in. I think you have a lot of stuff now to think and discuss about that, solidify your understanding. And we have cloud models. Yeah, this is a genuine text which keeps on evolving over time. I've been referring this documentation for the past 4 or 5 years. Initially, I was able to see only private cloud, public cloud, and hybrid cloud. Now I am able to see further categories. They are continuously upgrading this documentation. They are adding something to it. Yeah, cloud models. No, that's one kind. So now we are like a blind people trying to touch a big elephant, and we have a lot of features. I touch the tail and say this is how it feels. I touch one of the legs with both my hands and say this is how it feels. I go and touch the trunk and say this is how it feels. And this is all something which is trying to define how the cloud will appear. We are all the blind people because we don't know anything, assuming that we don't know anything about cloud, and we are trying to feel it. What are all the different features that we are interested in? We want to know it one by one. So this is one such model, that is responsibility model. This is how the cloud is really deployed and how it works. Private cloud. Private cloud is something that it's a cloud infrastructure which is deployed in your company, within the company, as good as your data center, but still maintained by the cloud service provider. Because you don't trust a public cloud, because that is a shared asset. When you are not using it, someone else will be using it. If someone else is using it, you will really have a lot of doubts whether my data is secure or not. Are you really maintaining that hard and fast wall or firewall to ensure that your digital assets are never compromised in a shared digital infrastructure? You really have that kind of doubt, then you 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 again want the expertise of cloud service provider to be utilized to run your data center. Then definitely the cloud service provider is having arrangement called private cloud. They will set up the infrastructure, you will have to pay, and they will run it. They will have their people and their technology, their hardware deployed, their softwares and management softwares deployed. Their people may be working at your site, or they may be working from remote, trying to run that cloud infrastructure. That's called private cloud. It's still within your premises, and you can always be rest assured that no one is really intruding into your digital infrastructure. Some kind of assurance that you get, but it costs a lot. Greater costs and fewer benefits. Fewer benefits means scalability here is limited. Scalability, how much is the digital infrastructure assets that you can scale here, may be limited. Whereas in the public cloud, you have a lot of hardware. If someone is not using, on just in time, that will be added to your demand, and it will be scaled in an automatic way. So that facility may be reduced. So the benefit will get reduced in private cloud, whereas the cost will be more because you have something, if you go to a public temple, the cost of the temple, maybe, it is an investment made by the entire public. But if you want to build a temple in your home, then you can imagine the cost of it. You have to pay for the, that pandit who is doing puja to you on daily basis. You have to incur lot of cost to decorate the idol and all that. So something related to that, something you can compare it with that. Public cloud, yes, it's a shared asset, controlled and maintained by third-party cloud provider, with the kind of models, shared responsibility model that we have just now studied. Public cloud is there. Here you have the facility to scale. We have scaling models also that we'll discuss in some time. Hybrid cloud. Hybrid cloud is very good one. You can reserve some part of public cloud, and you can have private cloud as well. If your private cloud is up to its full capacity, then you can have some high bandwidth connection to the public cloud, and virtually your public cloud will get attached to the private cloud. Means scaling will not be restricted. You can expand the scaling into the private cloud, into the public cloud. Private cloud infrastructure can expand its digital infrastructure into public cloud, which means that it can balloon. So whatever is the limitation, that is network, that will be managed with high bandwidth uh, internet connections, like with fiber optic or some kind of, we have internet connections which are spanning up to 10 Gbps in recent days. They use that kind of networks to connect, to have connectivity between private and public cloud, and ultimately end user will not see the restrictions related to private cloud, since these are connected. Both of these we are making use of it, so we call that as hybrid cloud. Multi-cloud is nothing but, you see, my team may be making use of Azure, and the data, like you have upstream, midstream, and downstream datas. So the data which comes into our system may be coming in from Amazon cloud. So the applications in Amazon cloud may be receiving data from Google cloud, and you may have your digital assets spread across multiple cloud service providers. We call that arrangement as multi-cloud, because you should have the connectivity enabled. So it doesn't matter where your digital asset may be running in any kind of cloud service provider, you have to have connectivity enabled. That's a kind of, compatibility that you need to ensure. So that arrangement will call multi-cloud. Azure Arc. Azure Arc is some kind of, offering again. All of this will come at a cost. And VMware solution. And Azure would have been like, they would have made some kind of virtualization arrangement, VMware. So VMware is a kind of provisioning of VMs. You can have a very big server and make compartmentalization and do virtualization, and then you can have this. See, OPEX and CAPEX, this we have already discussed. CapEx refers to capital expenditure, which means that huge upfront investment into purchasing the digital infrastructure. OpEx is something that you have to run. Definitely both of this will be high if you are having a traditional on-premise data center. You have to put capital expenditure and operational expenditure because you need people to run that arrangement of on-premise data center, and their salaries keeps on increasing day by day. Every year you have to give appraisal, and then it's a kind of inflation that will be attached with it. So the benefits of cloud is, comparatively you can see no need to purchase and manage costly infrastructure, no upfront cost. You do not have to do all of this costly infrastructure management. You do not have to recruit people. You do not have to rope in third-party experts. If you are no longer using any resource, you need not have to pay that. If you are using a data center on premise, whether you use it or not, your digital assets will get old. No one can stop it. So it's better if you use it to the full extent, right? That's what you feel. If you have utilized only 30% and paid 100 rupees for it, which means that you have derived only 30 rupees benefit and you paid 100 rupees at the end of the lifetime of a particular server, then you will definitely repent for it, for not be making 100% utilization of that asset, right? Whether you use it or not, that will get old. Whereas in cloud, you need not have to worry about whether you are using it or not. If you are using, you are paying. Otherwise, you are not paying. So scaling is definitely a very good benefit. So you can plan your applications to run in a more efficient way. In that way, you can reduce your running cost. This comes in as additional responsibility on the shoulders of developers. So you do one-time investment with the kind of knowledge that you are having, you are able to run it more efficiently. That is going to save your running costs. Probably you may have, that is the reason why companies are putting more money into hiring engineers, really efficient engineers, because they are saving a lot of money when they are moving from the traditional data center to the cloud. You can calculate it. There will be calculators, kind of tariffs, how many computers, how much time I use, what will be the cost incurred. They'll give a kind of rough idea using that calculators.